Welcome to the Polygonology game answer key video. Hopefully you spent 20 to 25 minutes completing the 12 short scenarios. In this video, we'll review each scenario question and then look at the best answer. Keep in mind that in these scenarios, there may not necessarily be just one correct answer. There may also be more than one bad answers too, like having a polygon way too large or way too small. I've tried to provide the best answer that supports the best messaging of the threat. In each scenario, you'll see how to score your answer. Okay, so as you will recall, scenario 1 focused on an eastward moving tornadic supercell. You were asked to draw a better polygon that removes area that's not in danger from the hazards, which in this example was a considerable portion of the polygon. The white polygon is my suggestion of how best to draw it. First, remove area behind the mesocyclone where the threat has already ended. One has to be careful because sometimes a new radar scan may be coming in right before the warning is issued, leading to a result like the actual polygon shown in purple. Second, given the steady eastward motion of the storm, remove area north of the hazard where the threat is minimal, given a southeast storm tilt with height. And third, remove areas well south of the mesocyclone track that are also not in danger. Note that the white polygon still increases in width with distance downstream to account for some future motion uncertainty. In this illustration, I removed all the towns hidden by the purple lines because they were not in danger. If you drew a similar polygon, give yourself 5 points, or 3 points if your polygon is a bit larger but you still removed 3 or 4 towns from the warning, and 1 point if you just removed 1 or 2 towns. Now there is also the potential for drawing the polygon too small, as illustrated by the red dashed polygon, resulting in an increased risk of a missed event. If your polygon is similar to this red dashed one or smaller, give yourself just 1 point. Mark your score for this scenario on the lower right part of your answer sheet, scenario 1 slide. Okay, now that you're done celebrating or cursing your scenario 1 result, let's move on to scenario 2. It also focuses on drawing a more refined polygon. As you see, the threat is considerably smaller than the polygon, given a steady northeast motion. We want to focus the polygon on the area truly under threat, so that the locations impacted section focuses on those particular locations, and not ones outside of the storm's path. The white polygon is a best case solution, still reflecting some uncertainty of future storm motion, but removing the southern half of the purple polygon from the warning, thus removing 5 or more towns from the list where no threat exists. Score yourself just like you did for scenario 1. If you drew a similar polygon, give yourself 5 points, or 3 points if you drew a bit larger polygon, but still removed 3 or 4 towns from the warning, and 1 point if you just removed 1 or 2 towns. If your polygon is too small, as illustrated by the red dashed polygon, give yourself just 1 point due to the risk of a missed event occurring outside the small polygon. Note that the yellow dashed polygon represents the expected path of the mesocyclone, where the most significant hazards are likely to track. There is very little threat west of the polygon. Mark your score for this scenario on your answer sheet, scenario number 2 slide, along with the accumulated score for the first 2 scenarios. Scenario 3 focuses on this tornado warning polygon and associated text product for a marginal tornado threat from a very slow-moving storm. Hopefully you found all kinds of issues in this example. If you compare the storm location and locations impacted list from the text product to this map, you likely found a number of issues. The storm core, shown in the red oval, is heading for a community called Jacksonville North Estates, one that's not in the text product. The storm is not over Ocean Way, as indicated in the text product, nor will it arrive in Ocean Way 22 minutes later, as given in the pathcast. Talk about confusing. The pathcast then lists Jacksonville. If this references to downtown Jacksonville, well, that's in the other direction. Here is a listing of 6 issues I found. There might be more that I didn't recognize. Note the wrong description of the county portions for the polygon. I would have described it as northern or north central Duval County and maybe far southern or extreme southern Nassau County, but not central Nassau County, which is here, or northeastern Duval, which is really over here. So it doesn't quite describe it correctly. If the storm is moving at only 5 miles an hour, it's not going to get to Nassau County. So we have a little clipped county here that's going to alert the entire county on weather radio, a county that we may not really have wanted to alert in this case. We have a wrong storm location. It is not over Ocean Way. A confusing indication of Ocean Way arrival time in the pathcast. And then a confusion as to what Jacksonville is being referred to, downtown Jacksonville being in the other direction from where the storm is moving. And that the main location in danger was not mentioned in the text product. Give yourself 5 points if you find at least 5 of these issues. These could include others that you find that I missed. Give yourself 3 points if you find 3 to 4 issues, and just 1 point if you just find 1 or 2 of these. Once again, mark your score for this scenario and the accumulated score for the first 3 scenarios on the lower right part of your answer sheet on the scenarios number 3 slide. Scenario 4 focuses on a messy display of polygons. Your task was to clean up this mess through updates or new warnings to minimize polygon overlap. Now, slight overlap of polygons is okay given the lower resolution of the AWIPS maps, but too much can end up confusing those who receive the warnings. So how would I have cleaned this up? Given the latest radar trend, I would have canceled 3 of the polygons shown by the white X's. Given that the storms are now in other polygons, I would update 4 of the polygons with my updates shown in white, removing a lot of area behind the hazards where there's no longer a threat. Finally, I would issue a new warning, either severe or TOR, depending on what the radar was showing, as shown in yellow. If you look at the white and yellow polygons, you'll note that there is minimal overlap, and there is minimal area not in danger that's within these polygons. So I made 8 total adjustments. If you made at least 6 similar adjustments, give yourself 5 points, or 3 points for 3 to 5 of the adjustments, or 1 point for just 1 or 2 of them. Scenario 5 focuses on 3 tornado warning polygons with considerable overlap. How could we have generated a less confusing result, especially polygon number 2, which was just issued? I would have updated polygons 1 and 3 to remove area where there's no imminent threat from the covered storms. For polygon 2, I would have had a different polygon issued, given that polygon number 1 has the hazards covered until they move out of the polygon, so no need for overlap. My new polygon, number 2, would not overlap number 3 because of my polygon update to keep that polygon focused on the lead supercell. So I let number 1 cover the trailing storm and focused number 2 on the area ahead of the upstream polygon, number 1. Thus, minimal polygon overlap. Note the scoring guidelines shown. Now, if you draw your polygons too small, you get 0 points for that part of the scoring due to the risk of a missed event. Give yourself an additional point or 2 based on updating the other polygons. For scenario 6, we focus on a new warning polygon that overlaps a prior one 30 minutes before it expires, and the text product for the new warning. Note that there are 2 potential tornado hazards detected. The new warning focuses on the lead circulation northeast of Dakota City, but the polygon is drawn to cover both circulations. The challenge of this scenario was the fact that there was more than 1 tornado hazard, 2 in fact, while WarnGen generally focuses on 1 hazard, as shown in the text product. 4 issues are noted here. First, no reference to the second tornado hazard following behind the one that's mentioned in the text product. Secondly, given a northeast motion, there's very low probability that the southernmost towns would be in the path of the hazards. Third, the storm that's located northeast of Dakota City, moving northeast away from the town, is still mentioned in the location's impact list, which can be confusing. And fourth, there's potential confusion with the large polygon overlap. It's better to update messaging for the original polygon and remove polygon area upstream from the mesos and west of their path, and focus a new polygon for areas downstream of the original polygon, as suggested on the bottom image. You were not asked to draw polygons here, but if you were, the best answer key is shown on the lower image, with an update to the prior polygon shown in white, and how I would have drawn the new tornado warning in yellow, trying to minimize overlap as much as possible. So for scoring, if you recognize at least 3 of the issues shown, or even others you might see that I did not see, give yourself 5 points. 3 points for finding at least 2 issues, and 1 point for finding just 1 issue. Again, if there are issues you find that I did not, you can incorporate those in the scoring. Scenario number 7 focuses on a slow-moving pulse severe storm with downburst potential. This 1-hour warning polygon is much too large, both in time and area, since such hazards usually last just 15 to 30 minutes and are usually confined to areas near the storm downdraft. Thus, I would have something close to the white polygon for a 30-minute warning. It's uncertain whether the hazard will get to the town of Byron before weakening, but I might include it in the polygon due to some uncertainty. In this example, roughly 75% of the polygon that was originally issued is false alarm area, where there's no meaningful threat. Score yourself as indicated on this slide. Scenario 8 focuses on another pulse storm case for a storm moving very little, yet within a large polygon for a 45-minute severe thunderstorm warning. The threat is essentially confined to areas very close to the current location of the storm core. As downburst winds spread away from the core, the speeds decrease. Thus, the threat for severe winds is generally confined to areas beneath the collapsing core. However, given some uncertainty as to whether the storm drifts in a particular direction, the white polygon is drawn just beyond the core in all directions. Score yourself 3 points if you are close to this, and 1 point if you draw a larger polygon, but smaller than the actual one in red. Then add 2 points if you indicate at least 3 of the polygon or text products issues. Then add 2 points if you indicate at least 3 of the polygon or text product issues listed, or 1 point if you just indicate 1 or 2 of them. For scenario 9, focuses on an interesting case where the warned storm turns and escapes the polygon, and the actions that are needed in response. So I would cancel the original warning, marked by the white X, and my new polygon would be the yellow one shown, given very little threat north and east of this area. Compare this to the actual new warning polygon issued, with considerable false alarm area north and east of the storm track. Give yourself 3 points for drawing a similar new polygon, or 1 point for either drawing it too small, as given by the red dash polygon, or drawing one with an incorrect motion vector, given the new motion of the storm. Then add 2 points for canceling the northern polygon, given the end of the threat there. For scenario 10, we focus on a large, severe thunderstorm warning polygon covering 2 hazards, but the text product only refers to one of them. For the polygon itself, I would update it as shown in white to remove much of the polygon where the threat is ended. Also note the text product issues discovered, particularly one where we actually have 2 potential severe storms, even though one is mentioned in the WarnGen text product. One may have to manually type in information about the second threat. Score yourself as indicated on the slide. Scenario 11 provides another messy case involving mesovortices along a QLCS. Our focus is on trying to provide a less confusing result. This is a more challenging case. Dealing with mesovortices along a QLCS can be tricky, usually leading to a large severe thunderstorm warning polygon for the wind hazard, which can be widespread, and embedded smaller tornado warning polygons within it. Based on how this was set up, I would update the northern severe to remove area no longer in danger. I would do the same for the tornado polygons, but in a manner that reduced polygon overlap. So in this example, I probably would have focused the southern torch just on a mesovortex south of the northern polygon until it crossed into the northern polygon, thus minimizing overlap. Scoring for this scenario is shown in the bottom of this slide. For the final scenario, focuses on removing area in an update where no threat exists. Sometimes uncertainty dictates a larger polygon, but over time, once a clear motion is set, updating the polygon to remove areas not really in danger is important. The threat of a large tornado along with hail or wind is really confined to the northern half of the polygon. So my update polygon would look like the white one, removing areas to the south where there's no threat, given the mesocyclone track well to the north. You can score yourself 3 points if your polygon is close to the white one, and 1 point if it's closer to the original one in purple or one that is too small, like the red dash polygon, in which the tornado could prematurely exit the polygon. Note that 5 issues are found here. Score an additional 2 points for correctly indicating at least 3 of these issues with the polygon or text product, or 1 point for indicating 1 or 2 of them. Mark your scenario score and your total accumulated score for all 12 scenarios in the lower part of your answer sheet, scenario number 12 slide. Now compare your accumulated total score with a maximum possible value of 60 to the table shown here. While it's great if you score above 40, what's most important is the ability to recognize these issues and to correct them when you have the ability to do so in future events that you work. Thank you for completing the exercise. Now, the answers provided are based on what I would recommend, but may not be the only correct solution. So if you have any questions about the exercise or any of the scenarios or your result, discuss it with your local office SUE. My hope is that you have a better understanding of the issues to look for to correct in order to provide a better end result to support better decisions. Finally, please review the last slide in the PowerPoint answer key. It describes a number of issues that were incorporated into this exercise, be it issues that require you to correct the text product or issues that require you to redraw the polygon and redesign the text product. If you have any questions about these, please discuss them with your local office SUE. Thank you.